of whether the interface is down or not. Can be pinged. If it is down, switch to the backup line. My problem now is, this end of the line is fine. But if the interface on the opposite end is down, the flow cannot be switched now, because I'm already shut down now. Okay. Let's verify. Actually, let's see if the routing of R7 is correct. I'll check it now. Show IP route. You will find, obviously, the device on the right. Enter the 00 interface. Already shut down. And now this state. It is indeed down. Then why is the next hop here still 10.1.1.2? This interface has been down. But for the device on the left, it does not know that the interface is down. Its current next hop in the routing table, still this interface. Then the future data will go to 8.8.8.8. It will still forward according to this interface. But now there is a problem with the physical state of this interface. Then data traffic is sent. It is impossible to receive. So you will find, if there is a route, it will receive the data. If no route, it directly lost the data going to 8.8.8.8. There is now a local route. It checks the routing table and forwards to the next hop. There is now a problem due to the next hop. Then actually, data here. It is impossible to receive. So, there was a problem when data was transmitted on this link. This phenomenon is called routing black hole. When a data arrives on a device now, this device obviously has a route to the destination, and also perform data forwarding on the data. But the data didn't reach the destination. This phenomenon is called a routing black hole. When you learn BGP in the NP phase in the future, we'll touch it. This is a very typical phenomenon. What we are talking about today is also called routing black hole. Do you know how to solve it? Certainly. NA stage will not talk about this thing. I just want to mention, we will learn a little tool in the future. It is a link detection mechanism of Cisco, called SLA. This will be learned in the NP phase. Now the problem is that this interface is down. But this device is not aware, since it has no way to perceive. So it has no way to know that the interface is down now. That's why I added a switch in the middle. Direct connection of devices is also called direct connection. Actually, it has two cases. A direct connection in the physical state. That is, there are no other devices in between. The inner end of the interface of one device is the interface of another device. This is called direct connection in physical state. For the R7 and R8 we talked about today, a switch intervenes between them. This kind of direct connection is called logical direct connection. The switch does not affect the real data forwarding, but it affects them not being directly connected anymore. This interface is down due to the intervention of a switch in the middle. This interface cannot perceive that it is down. If they are directly connected, it's down. This interface is also down, because this interface can directly sense that the peer link is down. This link is no longer available. But because a device intervenes, it is imperceptible. So we will learn a method in the future. Let R7 perceive that the 00 interface of R8 is down. Then switch the route to the following line. Rely on the technology of SLA. This is a Cisco link detection mechanism. The device on the left keeps sending messages to the device on the right to detect the carrier A nature of this interface. If it works, we'll reply to the device on the left. Then finally bind the SLA to the above route. That is, bind the SLA to this route. This is the route of the main line we are using now. in the future, through a detection mechanism such as SLA, to detect the other party's interface. If the peer interface is down, then the SLA is down. Since it is bound to this route, then this route will be down. Down means to come out of the routing table. It no longer does normal data forwarding. Then the following line will reappear in the routing table. That is, I pass a detection mechanism. Check the status of the other party's interface. If the status of the peer interface is down, SLA will be down. Due to the SLA and this static binding, then this static route will also be down. Then if this static route is down, let's go back to our original idea. If the above line is down, the following line will float to the routing table. It is also a floating static route. Let's not talk about this configuration now. Only in the NP stage. But you need to know this. Okay. Let's move on. Default route. Actually, I told you before. For current equipment, RA wants to reach the network segment behind RB. You will find it has entered 3 network segments here. Then in theory, if I configure it here, how should I configure it? IP route 192.168.1.0, 3255 and 10. The next hop is 12.1.1.2. This is the first. If the data wants to go to 2.0, IP route 192.168.2.0, 24-bit mask. The next hop is also 12.1.1.2. The third is the same. You will find, as long as this network segment is behind the RB, which network segment does the data actually go to? The next hop is the left interface of RB. So traffic will be sent to RB anyway. For this case, we can enter a default route. It is represented by 4 zeros. The next hop points directly to 12.1.1.2. That is, as long as the data goes to any place in the future, can send traffic to RB. Of course, the premise is that there is no precise route in the routing table. For example, a route is now entered in the routing table. 192.168.1.0. 24-bit mask. Then if there is a route to the 1.0 network segment, it will match the following. Does not match the above. I should have told you about this in the last class. Let's take a look at its configuration. IP route. For example, I now simply configure a route for it. 0.0.0.0. The mask is also 0.0.0.0. Suppose the next hop is 10.1.1.2. Okay. Let's check. Just check the status. There is now a default route in the routing table. The reason why I entered this command for you. I want everyone to see this phenomenon. That is, the form of the default route. In the routing table, it will be denoted by an asterisk S. When none of the routes can match in the future, match the default route. So where is this thing most used? I give a simple example. For example, on PC. PC has a default route. We can check it out. Route print. There is now an IPv4 routing table. The host also has a routing table. Now the mask is 0.0.0.0. The reason is not 4255. Because there is a longest mask matching principle.